This is question 10 on page 227. A rubber ball with mass 0.25 kilograms is dropped from a height of 1.5 meters onto the floor. Just after bouncing from the floor, the ball has a velocity of 4.0 meters per second up. So the first part of the question asks, determine the impulse imparted by the floor to the ball. So the first thing that we are going to do is list our givens. So these are all of the values that we know. We know the mass, the value for delta y, the final velocity, and what we need to know is the impulse. So to solve this question, it helps to recognize the fact that kinetic energy is equal to the gravitational potential energy. So we know that kinetic energy is equal to half mv squared, and gravitational potential energy is equal to mg delta y. So we can cross out the mass since it is present on both sides, and then isolate for v, giving us the velocity is equal to the square root of 2g multiplied by delta y. We sub in our values, and then we come up with the value of 5.42 meters per second down, or negative 5.42 meters per second up. Now that we have this value, we can substitute it into the formula for impulse. So delta P is equal to the mass multiplied by the difference between final velocity and initial velocity. So we sub in our values, and then we come up with 2.36 Newton seconds up, which we rounded off to 2.4. So now the second part of the question asks, if the average force of the floor on the ball is 18 newtons up, for how long is the ball in contact with the floor? So again, we are going to list our givens. We know the impulse from the last part of the question. So again, that was 2.36, even though we rounded off to 2.4. The force, and what we need to know is the time. So this is fairly simple. We know that force multiplied by time is equal to delta P. So we can rearrange that, and then we can solve for the time, which ends up being 0.13 seconds.